This is Unit 8, back at Chapter Problem Question 4. So we can see in this problem here we have a source of IT, or a total current of being 800 milliamps, or 0.8 amps. We have R1 of being 1500 ohms, R2 of being 910 ohms, R3 of being 2000 ohms, and R4 equaling 3600 ohms. So our first step here is we're going to have to say that R3 is in parallel with R4, and we're going to call that combination 1, or equivalent resistor RC1. So I'm going to circle R3 and R4, call this RC1. So RC1 is equal to R3 in parallel with R4. Solving for this, we get 1 over R3 plus 1 over R4. So this equals to 2000 inverse plus 3600 inverse, and we have to inverse the total there. So solving for RC1, we get a value of 1285.714 ohms. So we're going to draw our new equivalent circuit. So we still have R1, and over here we still have R2, but R2 now is in series with RC1. So again, we can see that R2 is in series with RC1. So I'm going to circle R2 and RC1. I'm going to call this new equivalent resistance RC2, or R combination 2. So solving for RC2, so RC2 is equal to R2 plus RC1. Plug in some values in here, we get R2 of 910 ohms, so we get 910 plus RC1, which is 1285.714 ohms. Solving for this, we get a value of RC2 of 2195.714 ohms. So let's draw our new circuit. So we still have IT. We still have R1. And R1 is now in parallel with RC2. So again, we can see R1 is in parallel with RC2. I'm going to circle these two resistors, and we're going to call this RT, or our total resistance. So RT is equal to R1 in parallel with RC2. So this equals 1 over R1 plus 1 over RC2. Putting some numbers in, we get for R1 of 1500 inverse plus our value for RC2, which is 2195.714 inverse. Doing 1 over that answer, we're going to get a value of RT. We're going to get a value of RT as being 891 0.187 ohms. So we can simplify our circuit one more step here, where we have IT, now we just have one resistor, RT. So using Ohm's law, if we know IT, we know RT, we can calculate ET. So ET is equal to IT times RT, which equals to 800 milliamps, or 0.8 amps, times RT of 891.187. Solving for this, we get a value of ET as equaling 712.95 volts. So again, we just solved that ET equals 712.95 volts. So that would be ET here. But this circuit here is equivalent to the one we've drawn above. So again, we know ET here as being 712.95 volts. And the rule for parallel voltages is that any load connected in parallel is the same. So we can say that ET is equal to E1, which equals EC2, or the voltage drop across RC2, which again, that equals 712.95 volts. So our next step here is, if we know the voltage drop EC2, and we know the resistance RC2, we can calculate the current through resistor, or this equivalent combination circuit 2, RC2. So we can say that IC2 is equal to EC2 over RC2. So this equals to 712.95 volts divided by RC2, which we solved RC2 as being 2195.714 ohms. In solving for IC2, we get a value of 324.7 milliamps. Again, that's the current going through this branch in the circuit. But if we look up at our equivalent circuit above here, right, where do we get RC2 from? We got RC2 from a combination of RC1 in series with R2. So if we solve for the current through this branch here being 324.7 milliamps, we know the current through this branch, or the series circuit here, as being 324.7 milliamps, because again, current in a series circuit is the same. So our next step is, we have IC2 is equal to I2, which equals so again, our current through RC2, or what we call IC2, is equal to the current through R2 and the current through the resistor RC1, or IC1. Which that equals 324.7 milliamps. So if we know the current through these two resistors, we know the resistance R2 and RC1, we can calculate the voltage drop here and here. So let's calculate the voltage drop across RC1. So EC1 is equal to IC1 times RC1, just using Ohm's law. So this equals to 0.3247, or 324.7 milliamps, times RC1, which we calculate RC1 as being 1285.714 ohms. And solving for this voltage, we get a value of EC1 as being 417.47 volts. So we just solved for the voltage here as equaling 417.47 volts. Now where did the value RC1 come from? RC1 came from resistors R3 and R4 in parallel. This is RC1 down here. We just calculated the voltage drop here. RC1 is being 417.47 volts. But we know voltages in a parallel circuit is the same. So we also just calculated the value E3 and E4. So our final step here, we have EC1 is equal to E3, which equals E4, which equals 417.47 volts. So let's write down what we solved for. So we solved that RT is equal to 891.187 ohms. We solved that E1 which is equal to ET, E1 is equal to 712.95 volts. Again, we solved ET here as well. ET is equaling 712.95 volts. We solved that I2 is equal to 324.7 milliamps. And we solved that voltage drop across resistor 3, or E3, is equal to 417.47 volts, which also equals the voltage drop here, E4. So this is now Unit 2 problem, where we can solve the remaining unknowns using Ohm's law, E equals IR and P equals EI.